Into an intro to variation of parameters. So the idea here is if we have equation P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y equals f of x. And if we know a fundamental set of solutions for the homogeneous equation, so we know a fundamental set of solutions to P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y equals 0. So we'll take a fundamental set of solutions y1, y2. The general solution for the homogeneous equation would be y equals c1, y1 plus c2, y2. What we're going to do is we're going to swap those constants out for unknown functions, u1 and u2. So we are going to assume that y equals u1 of x times y1 plus u2 of x times y2 is a solution to the original equation. So this is actually exactly the same thing that we did for variation of parameters for first order linear. The homogeneous general solution was just a constant times our y1, and then we just swapped that constant out for u1. So essentially all we're doing is we are taking the homogeneous general solution and swapping out the constants for functions u. So putting this all together in a process, let's suppose, or we'll consider again, P0 of x. This is sloppy, I apologize. P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y equals f of x. And suppose that y equals c1 times y1 plus c2 y2 is the general solution to the homogeneous equation. Then what we are going to do is we are going to assume y equals u1 times y1 plus u2 times y2 is a solution to the original P0 of x, y double prime, plus P1 of x times y prime, plus P2 of x times y equals f of x. Now, something very important to note here. Note, since we have two unknowns, we'll need two equations to solve them. So we have u1 and u2 both unknown. We'll get two equations to solve for them. The differential equation is one of them. there is no other second equation, which means we get to pick the second equation so that it's pleasant. So we get to pick the second equation. Right? Anytime we have an equation with two variables and we want to solve for them, there are infinitely many solutions until we have a second equation. So we get to pick a second equation that makes the problem more pleasant. So we're going to plug y equals u1 times y1 plus u2 times y2 into the equation, into the differential equation. And doing that will require solving for y prime and y double prime. So we have y equals u1 times y1 plus u2 times y2. We will have y prime, that's not y prime, sorry. Y prime is equal to u1 prime times y1 plus u1 times y1 prime plus u2 prime times y2 plus u2 times y2 prime. Now, since we can pick whatever equation we want as our second equation, we're going to pick an equation that allows us to simplify y prime. So what we are going to do, sorry about that, is we are going to pick u1 prime times y1 plus u2 prime times y2 as equals 0 as our second equation. This simplifies the formula for y prime. And so we get then that y prime is simply u1 y1 prime plus u2 times y2 prime. So this is key here that we have picked our second equation now. And so we have two equations with two unknowns, u1 and u2. Our y double prime is therefore u1 prime times y1 prime plus u1 times y1 double prime. And then we have plus u2 prime times y2 prime plus u2 times y2 double prime. So we have, here's our equation for y, our equation for y prime, and our equation for y double prime. So plugging these in, plugging into P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y equaling f of x. We wind up getting, we have P0 of x multiplying u1 prime times y1 prime plus u1 times y1 double prime plus u2 prime times y2 prime plus u2 times y2 double prime. Then we have plus P1 of x times y prime, which y prime was u1 times y1 prime plus u2 times y2 prime. And then finally we have plus P2 of x times y, and y was u1 y1 plus u2 y2. All of this should equal f of x. So from here, we're going to go ahead and rearrange this. So rearranging this, we get, we only have P0 of x times u1 prime times y1 prime containing u1 prime. So we have P0 of x times u1 prime times y1 prime is our u1 prime term. we have P0 of X times Y1 prime times U1 prime. If we look for a U2 prime term, there's just one of those as well. And so that term, we have P of 0 or P0 of X times Y2 prime times U2 prime. And now let's go ahead and focus on our U1 term. So for U1, we have P0 of X times U1 times Y1 double prime. We have a plus P1 of X times U1 times Y prime. And we have a plus P2 of X times U1 times Y1. So this becomes plus, we have a P0 of X times Y1 double prime plus a P1 of X times Y1 prime plus P2 of X times Y1, all multiplied by U1. Then similarly, we have a P0 of X times U2 Y2 double prime. We have a P1 of X times U2 Y2 prime and a P2 of X times U2 Y2. So putting those together, this becomes P0 of X times Y2 double prime plus P1 of X times Y2 prime plus P2 of X times Y2, all of that times U2. And this is equal to f of X. Now the key here is our part that was the green zigzag. This is just the homogeneous, the left side of the equation with Y1 plugged in. So this green squiggle, this is just the left side of the equation. With Y1 plugged in. And Y1 is a homogeneous equation, or sorry, a homogeneous solution. So that just goes to 0. So, but Y1 is a homogeneous solution. So this is just 0. So this whole first component just goes to 0. The whole component multiplying U2, what I circled in brown. This is the left side of the equation with Y2 plugged in. And again, but Y2 is also a homogeneous solution. And so we get that this is equal to 0. And so our equation simplifies down to, so our equation simplifies to P0 of X times Y1 prime times U1 prime plus P0 of X times Y2 prime times U2 prime, right? And then all the rest is plus 0. This equals f of X. Or rewriting this, we get Y1 prime times U1 prime plus Y2 prime times U2 prime is equal to f of X over P0 of X. So our two equations are now So at this point, we have the system we had our equation we assumed originally that u1 prime times y1 plus u2 prime times y2 was equal to 0. So we have the system y1 times u1 prime plus y2 times u2 prime equals 0. And then this equation we just found, y1 prime times u1 prime plus y2 prime times u2 prime is equal to f of x over p0 of x. So again, this top equation, this is the equation we picked. And this is the simplified differential equation. With y equaling u1 times y1 plus u2 times y2. So ultimately, what we will be using for variation of parameters is we will be able to skip straight to this scenario here. Once we have this, we can solve the system. For u1 prime and u2 prime. And then we can integrate to find u1 and u2. And then y is equal to u1 times y1 plus u2 times y2. So the main thing here, again, is, oh, I need to update my screen. I apologize. So if we kind of summarize the steps. We need to find a homogeneous general solution or find a fundamental set of solutions. To the homogeneous equation. Once we have done that, we assume y is equal to u1 times y1 plus u2 times y2. From there, we get the system. y1 times u1 prime plus y2 times u2 prime equals 0. And y1 prime times u1 prime plus y2 prime times u2 prime is our f of x divided by p0 of x. From here, we solve the system. For u1 prime and u2 prime. Then we solve for u1 and u2. And then we finish off by finding y equals u1 y1 plus u2 y2. So I was going into kind of the theory of where this system of equations comes from. You do not need to rederive this system every time. You are welcome to just jump straight to the system of equations and then solve it. So in the next video, we will do an example of just that.